Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to discuss about how to perform hypothesis testing in Anova. So I can also give it something called as partitioning of variance in Anova. So already in Anova what do? We specifically compare mean of two or more groups, and we consider variance in that specifically. We'll discuss about like how the hypothesis testing is performed step by step, and we'll also solve a problem with respect to this. Okay, so to begin with, happens is the first step is that we basically define our null hypothesis. So null hypothesis, as you know, we compare the mean of two or more groups. So my null hypothesis is nothing but mean 1 is equal to mean 2 is equal to mean 3 based on how many number of samples we have, mean k, right? So this is basically our null hypothesis where we are comparing whether all the means are equal or not. Okay. Now coming to the alternate hypothesis. Now alternate hypothesis is specifically, we can also go ahead and write it like H1, and here we are basically going to say at least one of the mean is not equal. Okay. One of the sample mean. Okay. One of the sample mean is not equal. Okay. Is not equal. Now you may be thinking, Krish, why can't we just write a notation something like this? Mu1 is not equal to mu2 is not equal to mu3 or up to mu k, right? Is not equal to. Can we write like this? Understand one thing, guys, we cannot write like this, because in this case, right, we are strictly saying that all the means are like one mean is not equal to the other mean is not equal to the other mean. But here above I have just written at least one of the mean is not equal. Okay. Now with respect to performing this, we specifically use a test statistics which is called as F test. Okay. So the kind of test statistics we use, it is basically called as F test. So here we basically use F test, and the formula is very simple, guys, but it will definitely take a lot number of steps to basically do the F test itself. So F test is nothing but it is basically the variance between samples. Variance between samples divided by variance within sample. Okay. Within sample. I will make you understand what exactly this means. Okay. Variance within the samples. Okay. So this is basically the F test. Now let me go ahead and explain you. Let's say that I have three samples, x1, x2, x3. Okay. And let's consider with respect to this x1, I have 1, 2, 4, 5, 3. Okay. These are the elements that I specifically have. In x2, let's consider that I have elements like 6, 7, 3, 2, 1. And in x3, I have probably 5, 6, 3, 2, 4. Okay. Now let's consider this three samples, and I need to probably test whether the mean of this sample is equal or not. Okay. Like I really need to compare all the means with respect to this sample. Okay. And perform probably a F test as such, right? Now in this, in order to make you understand about this two important thing, that is variance between the sample and variance within the sample. At the end of the day, this mean is basically getting compared based on the variance that is present, right? So when we say variance within the sample, what does this basically mean? This is basically the differences between variance between your samples over here, right? So here, this is nothing but variance between samples. Okay. So in short, you probably calculate the variance of each sample, and then you probably try to find out the difference with one sample and the other sample. Okay. Now, similarly, we can probably go ahead and talk about this, right? This over here, we can also say variance between, sorry, not between, within samples. Now, variance within samples means what? Okay. Understand these things. Let's say that I have probably calculated the mean. Let's say this x1 bar for this is like 1 plus 2 plus 4 plus 5 plus 3 divided by 5. It is nothing but 3. Okay. You probably calculated. X2 bar is 7 plus 6 plus 3 plus 2 plus 1 divided by 5. Quickly, if I do it, it is somewhere around 19 by 5. And similarly, if I go ahead and write as 3 bar, is 5 plus 6, 11, 14, 18, 20, and this will be nothing but 4. Okay. Now in this case, when we say variance within the sample, so within this particular sample, if I have, see at the end of the day, what is standard deviation? Standard deviation basically means like variance is basically given by sigma square, right? If I talk about standard deviation, it basically says that a specific point, how much far away it is from the mean, right? With respect to variance, we basically talk about the spread, right? Now variance within the sample basically means with respect to this particular mean, how much these numbers are far or how number this different. Basically when we have this x1, right, I'm calculating the mean 3, right? Over here x1 bar is 3. But if we consider all these numbers, right, 1 is less than 3, 2 is less than 3, 4 is greater than 3, 5 is greater than 3, 3 is greater than 3. Now in this case, what is the difference when compared to the mean? That specifically talks about your variance itself, how different it is, right? So this is what we basically consider in order to calculate the F test in short, right? So for this kind of problem statement, obviously my null hypothesis will be nothing but x1 bar is equal to x2 bar is equal to x3 bar. And in the case of h1, it is nothing but at least one sample mean is not equal. Mean is not equal. And then we can probably go ahead and do it. Okay. Now what we will do is that I will try to show you one problem statement. Now this, when we say variance within sample, between sample and variance within sample, right? This is not a very simple step, right? There are multiple steps that is involved. We really need to calculate multiple things and then probably come to a conclusion. So please, I will show you one problem and then we'll try to see step by step. If you are stuck in something, I would suggest please re-watch the video, then only you'll be able to understand. So we'll take a problem with respect to one-way Anova. Now, whenever we say one-way Anova, it basically means one factor with at least two levels, and these levels are independent in short, right? So let's check this problem statement, and you will probably be able to get the complete idea. Trust me. If you're not able to get it, I would suggest please revise. See, it will be complicated because this is the biggest test that we have in statistical analysis. This will probably take more time, not with coding, but at least with understanding the theoretical part. Okay. Now over here you can see doctors wants to test a new medication which reduces headache. Okay, which reduces headache. They split the participants into three conditions. One is 15 mg, 30 mg, and 45 mg. Later on, the doctor asked the patient to rate the headache between 1 to 10. So after having that particular medicines, the three conditions based on that three different medicines, three dosage. I would suggest this is dosage, right? And medication is basically my factor. This is my levels, right? Now later on, the doctor asked the patient to rate the headache between 1 to 10. So they are basically, if they rate 10, that basically means the headache is completely gone. If they rate 1, the headache is there. Okay. Are there any differences between the three conditions using alpha as 0.05? Now this alpha is super important because we will try to find out the values of the F will basically refer the F table to find out the critical value also. And these are my data, like we have 15 mg, 30 mg, and 45 mg. This is with respect to one person, second person, third person, fourth person, fifth person, sixth person, seventh person. So total 7 people are there in this particular data set. Okay. And again, this rating is between 1 to 10. Now in this case, what is the first step? First step is basically we define now we want to compare this three samples in short, the mean of these samples, right? And we will probably be using variance, right? So define null and alternate hypothesis. This is the first step. Define null and alternate hypothesis. Now in this case, H0 is nothing but mean of 15, that is 15 mg is equal to mean of 30 mg, mean of 45 mg. So this becomes my null hypothesis. Alternate is that on at least or not all means are equal. Like we can say like this, or not all means are equal. Okay. Or at least one mean is not equal. Like that you can basically say. The second step that we probably see with respect to significance value, which defines our confidence interval. So this is nothing but alpha 0.05. Confidence interval is 0.95, right? So this is with respect to the second step. Now coming to the third step, which is super important, which is called as degree of freedom. So here I will try to calculate the degree of freedom. You have to follow these steps, guys. And based on that, we will be able to calculate the variance. Now with respect to degree of freedom, First of all, I will consider two important variables. The total sample size, like how many sample I have. So if we probably consider 3 rows, 1, 2, 3, 4, 5, 6, 7. 7 into 3, 21. So the total sample is 21. If I probably consider the sample size n, which is nothing but 7, and we'll also consider one value which is called as a, and this value is nothing but it is saying how many number of categories are there. Because this 3 will be super important in calculating the degree of freedom. Degree of freedom needs to be calculated between the 3 samples and within samples, right? So for this, what we do is that first of all, we really need to calculate degree of freedom between samples. And between samples, how do I do it? Because I'm considering with respect to 3 samples. So it will be very simple. A minus 1, which is nothing but 3 minus 1, which is nothing but 2. And then we'll go ahead and calculate degree of freedom within. Now degree of freedom within the sample, obviously it is simple. What you can do is that you can basically use this n minus a, right, with respect to the 3 categories. Okay, so this will be nothing but 21 minus 3, which is nothing but 18. And then finally you have degree of freedom total. Obviously this is very simple, n minus 1, which is nothing but 20. Now see this. Usually we used to use this degree of freedom total, right? And I'm getting the 20 value. If I combine this both, 2 plus 18, it is nothing but 20, right? In any ANOVA test, we try to find out these 2 things, degree of freedom between and degree of freedom within. So your range of values will be between 2, 18. Okay, so this will basically be your DF1 and this will be your DF2. And this is what is specifically used in Z table, not Z table. We basically say F table, okay, F table, along with your significance value 0.05 to find out the critical value. Now what exactly is this critical value? So 4th step, we basically construct a decision boundary, because we need to understand when to reject the null hypothesis and when to accept the null hypothesis, which you also say that we fail to reject the null hypothesis, something like this in technical terms. Okay, so usually whenever we try to apply an F test, it usually follows this kind of distribution. The right hand side is elongated, and what we do is that this region, we basically define this region as our 0.05 region, and this is basically our 0.95 region, the confidence interval. In short, this is my rejection area, and this is my acceptance area. Now based on this particular F table, I need to calculate what is this area. Okay, what is this critical value. Okay, so what I'm going to do, I'm going to probably quickly just minimize this and probably open my F table. Okay, just go and search for F table in Google. I know you are not able to see it because I've not shown you yet. So here you go. In F table, you can probably go and click this. Now in F table, you have for 0.10, you have for point alpha is 0.05. So I will go ahead and consider this. See, this type of distribution is right skewed distribution. Okay, here you have DF1. Obviously my DF1 value is nothing but 2 and DF2 value is nothing but 18, right? So this is what is the value that I'm probably getting from this F table, which is my critical value. Okay, so what I will do, it is very simple. I will write 3.5546. Okay, so I'll make this. So this critical value is nothing but 3.5546. Now, when we do this, right, it is very simple. We probably talk about the decision rule now. Now the decision rule basically says that if my F calculated value, like the F test statistics I'm going to apply, if that F value is greater than 3.5546, then it falls in this region, right? So what we do, we reject the null hypothesis. Very simple. We reject the null hypothesis. That is what we are basically going to do. Now is the most difficult thing, that we probably need to calculate the test statistics. So finally, if you probably see this step 4, 5th and 6th. So I will go and calculate my 5th step. So here I will go ahead and calculate the F test statistics. Okay, F test statistics. Now let's see how F test statistics will be calculated. Okay, now with respect to this formula that we have, right, I hope everybody have seen this formula, the variance between the sample and within the sample, right? So I'm just going to copy and paste it over here so that this will always be there so that we can refer it. Okay, Now this was the formula to calculate this. Now to get this right, there's so many things we really need to get. Okay. First thing that I'm going to find out is something called as sum of squares. Now sum of squares, I need to find out for between, then within. When I say between, that basically means between samples. This basically means within samples. Sum of square actually helps you to find out the variance. Okay. And then total. Okay. The second thing that I really need to compute is about df. Then the third thing is about ms. And finally, we get the f value. Okay. Now, whenever we say ms, it is nothing but mean squared. Okay. Now, first thing, let's go ahead and calculate this first row. SS between, SS within, and SS total. Okay. And we'll try to understand what is the formula. And before that, I will take this also so that I will have this table reference. Okay. So I'm just going to copy it over here. It's quite big, but don't worry, I will make it small. Okay. Okay, so this is my table. Okay. Now, first of all, I told you I need to compute, or let me just use this. Oops. Just a second, guys. I will use this over here. Okay. Now the things that we need to calculate over here. Okay. See, SS between. First of all, we'll try to calculate SS between. Number one, SS between. Sum of square between samples. So formula of this is basically given by summation of AI whole square minus T square divided by N, and this will be small n. Now what is this A of I, right? Now, in order to tell you about A of I, right? So, okay, this will be sample. In order to talk about A of I, right? See how I'll calculate this summation of AI whole square, okay? First of all, we'll go ahead with 15 mg. Now, with respect to 15 mg, AI, summation of AI basically means I will sum this entire sample. So, it will be nothing but 9 plus 8 plus 7 plus 8 plus 8 plus 9 plus 8. So if I probably calculate, it is 3 is 24, 18, 8 4 is 32. So it will be somewhere around 57. Okay. And then if I probably go ahead and take about 30 mg, and if I try to calculate over here, it will be nothing but 7 plus 6 plus 6 plus 7 plus 8. This 6 is over here. I think it's got swapped over here. So this will be 6. Okay. 7 plus 8 plus 7 plus 6. So if I do the summation, it will be nothing but 7, 13, 7, 8, 8, 3, 21, 18, and 14. Okay. So this will be nothing but 47. Okay. So I hope I'm doing the calculation right. Okay. Just try it out. But I think I've already done this kind of calculation. So it needs to be right. Okay. And then with respect to 45 mg, I basically have 4 plus 3 plus 2 plus 3 plus 4 plus 3 plus 2. So this is nothing but 21. Okay. So this is how I have calculated summation of A of I. Okay. With respect to this, in short, I've just done the summation of all the sample values. Okay. Now the next step that we specifically do over here is that we basically write it as summation whole square, right? Summation of A of I whole square. So this will be nothing but 57 square plus 47 square plus 21 square divided by what is small n. Small n is nothing but 7. And this side, T square basically means that I will take this value, the summation of all the samples, and I'll square it up. 57 square plus 47 square plus 21 square divided by 21. Remember guys, through this technique, we are able to calculate the sum of square, the error in the variance between the samples. Okay. And with the help of this, we will be getting this particular value. Okay. So it is nothing but 98.67. I know this is a little bit cumbersome, but understand if you follow the steps, you will be able to get it. Okay. Now this is done. I have calculated SS between. Now we'll try to calculate SS within, sum of square within the samples. So second one that we have is nothing but SS sum of square within samples. And this is given by the formula summation of y square minus summation of A of I whole square divided by n. Okay, we have already calculated this. This is nothing but this. But what about summation of y square? So summation of y square is nothing but what we do is that we take every value in the sample, we square it up. Okay, we just square it up. So probably you can just write like this, right? First sample 9 square plus 8 square plus 7 square. So if you probably see like this, 9 8 square plus 8 square 7 square plus 8 square plus 8 square. So like this you can probably do the calculation. So like this, take all the values and just do the squaring, and here you are probably going to get 853. So this will be nothing but the sum of square within will be nothing but 853 minus 57 square plus 47 square plus 21 square divided by 7. So here the total value that I'm going to get is nothing but 10.29. Okay. So once we do this, so let me put all these values. So it is 98.67 over here, 98.67, 10.21. So this will be nothing but 108.88. Okay. So this is what specifically we are going to get the value with respect to this. Okay. So I think 108 dot, so that is 10.21 or 29, sorry. So 10.29. So this will be 188.95 or 96. Okay. Okay. So what I will do, I will just copy this entire thing and paste it downwards. Okay. So it will be easy for me to write it over here. Now this is done. Specifically 98.67 is one calculation with respect to this. 10.29 is the other calculation, and finally I'll be able to get these all values. Okay. Now degree of freedom, obviously between, if you probably see degree of freedom between. So if you go and see over here, degree of freedom between is nothing but 2 and then 18. Okay. So here I'm going to get 2, 18, and this will be 20, right? Summation if you do this, if both we divide it, see mean square is very simple. We just take this value and divide this with this value, right? So here I will be getting 59.34 and this will be nothing but 0.54. This also we are trying to divide by this. And once it is done, you can also sum it up and you can get it. And finally, now if I talk about this value, right? F test. So here F test is nothing but this specific thing, like variance between the sample. But in this case, what we do with respect to F test, we just take this MS between, which is equivalent to this variance between the sample. And then we have MS within, which is equivalent to variance within samples. So finally, when you take this and you just divide 49.34 divided by 0.54, here you're specifically going to get 86.56. So finally, this is my F test value. Now we know that if F is greater than 3.546, I guess, right? Let's see. It is very difficult. 5546, okay. 3.5546. Then what we do? We reject the H0, right? So in this case, obviously 86.56 is greater than 3.5546. So we reject the null hypothesis. So in short, the conclusion that you can probably make from this thing is that, are there any differences between the three conditions? Obviously there is differences within this three conditions that you have. So your null hypothesis is getting rejected, right? This is not true. So not all are equal, or not any one of them are equal, right? At least one of them are not equal. In short, you can basically make those kind of conclusions.